Alright, here is our challenge question of the day. So this is actually from a past CS61A exam, and CS61A exams at Berkeley are, by the way, known to be notoriously difficult in their questions. So this is quite a challenging problem, and let's just take a look at it. And I'll walk through how I would approach this problem, and I want to spend quite a bit of time on this problem because I think this is a very instructive problem. And I'll actually go through like basically cold. I'll probably make some mistakes. We'll learn from those mistakes, and then I'll probably figure out the right answer to the solution. So let's take a look at this. So the longest increasing suffix n. Okay. So what's interesting about this exam is that they always provide some scaffolding for us, and that's nice, but it also shows a good skill in that a lot of times when you are out there actually coding, you're working with a team, and your team is going to be, different members of your team are going to be coding, and you have to work with their code, and you have to be able to understand their code, and then write your own programs to work with their code. So this is a good skill to have, to be able to identify code and basically be able to work with it. So let's take a look at this problem. I've loaded it up on the text editor, and I'm actually going to go full screen for this one because it is, it's an important question. So let's go. So we want to return the longest increasing suffix of a positive integer n. What does that mean? Well, let's look at some examples. So we have the longest increasing suffix of this number. It ends up being 134. Well, hey, the last part of this number that's increasing is 134. If we go left to right, this is increasing. Okay, then if we do this number, oh, it's only 3. So here we get an important point. It has to be strictly increasing. So 3 is not strictly increasing because 3 is equal to 3. Okay, then now we have another example where we deal with 5, 6, 8, 9. Okay, interesting. So this, again, strictly increasing. 5 is less than 6, 6 is less than 8, 8 is less than 9. And then here, what's the last example we have? Oh, the last increasing sequence is 0, 1. Well, 0, 1 is just 1, so it shows us that case too. So these are pretty good doc tests. Okay, so now let's look at the code. So we have some variable m, don't know what it is. We have some variable suffix, okay? We can assume that this is what we're returning at the end, so this is the answer. This is the answer. This is our answer. Okay, cool. Now, k is some 1. We don't know what that is right now. Okay, so then while it's the case that n, so again, we have that similar structure, so we're going to be doing some digit processing. So again, right now I'm just going to be reading through the question and kind of making some preliminary conclusions on exactly what's going on. Okay, and then we have the last digit. Okay, this is standard. We get n modulus 10, and then we have n. Well, from my experience with these previous problems, I know that I need to convert to n, and most likely it's going to be n divided by 10. So I think this is actually a pretty easy part of this problem, and I'm just going to put n divided by 10. And again, anytime you have some thoughts, of course it's good to think about it, but sometimes a lot of people get just hung up on thinking about it so much that they don't get any code on. And again, I don't know if you guys are ever going to be taking CS61 or taking these type of exams. You do want to keep yourself moving. Okay? So, now, the next part is basically the rest of this I need to figure out is this if condition. Okay, so if something happens, I reassign m, suffix, and k. Okay, and otherwise I return the suffix. Well, what would be the case where I would immediately return the suffix? Well, that case would be if, let's think. Well, in this case, I stop when I realize I'm done increasing. The next digit, the current digit is going to be greater than the previous digit. Okay, current being the leftmost, previous being the rightmost. I'll probably mix those two up, but I'll try to be clear. Okay, so basically, if I encounter a digit that's greater than the previous digit, I need to stop. Okay, so taking the opposite of that, I don't know if this is right, but I'm just going to go ahead and see if I can get something to work. So, what do I have right now? I have the last digit, so this is going to be, so in this case, it's going to be 4, okay? So I'm actually going to label all this. I like to label things, and I think this is a good skill to have. So the last digit in this, I'm going to work only with this example for now, and then maybe I'll expand. So last is 4, and my n after I execute this line is going to be, what is it going to be? 6313. Alright. And so now I want to make sure that this digit is less than this digit to make sure that it's increasing, strictly increasing, right? So what I'm going to do is I don't know if this is right now, but if n modulus 10, that's going to get me my 3, right, is less than my last, I want to execute this, okay? Now the tricky question now is how am I going to calculate the suffix based on this? Well, the suffix right now is going to, I want it to be 34, right? So let's think about how I want to get it to 34. Okay, so I have my n modulus 10, and I want to basically, so my n modulus 10 is 3, right? And I want to get 34. How do I do this? So, I can do 3 times 10 plus 4. Do I have a variable that's 10? Oh, hey, I have m is 10. Okay? Again, I'm not exactly sure if this is going to work, but I might as well try, right? A lot of times when you're coding, a lot of times you don't know exactly what you're doing, but if you try some stuff, you might get some insight into how to approach the problem. So, what I'm going to do is I'm going to take my n modulus 10, and I'm going to multiply it by, what should I multiply it by? I should multiply it by m. And what I think m is right now is that it's a second multiplier. So every time through, I want to multiply this by m again. So 10 times m. So this is my initial feeling on what this problem, the solution is. And I'll verify it later. So I want to multiply it by m. And then what I want to do, I want to add it to k times the last digit. And then of course I want to add it to the previous suffix because we're building off from previous suffix. Okay, this is a pretty long expression. So I don't know, I really don't feel good about this being this complex. So, but let's just see what happens. So this is initially what happens. So now let's look at second iteration. Okay, the second iteration through, what's our new m is 100, remember? Our new k is 10. So then what do we have? Our n modulus 10 is going to be, what is it going to be? It's going to be, let me think. N modulus 10 is going to be 1, right? Because our n is now going to be 631. Okay, and then what else do we need to know? Our suffix currently is going to be 34, and our new last digit is going to be 4. So a lot of variables to keep track of. So this is why you should write this all down. Okay, so now we want to make sure that after all of this, suffix ends up being what? 134. We want this to see whether this is true. Okay, so we only really need to focus on this. Okay, so let's work this out. N modulus 10 is 1, okay, times n, m, which is 100, so that's 100. 100, so this part's 100. So this part's 100, okay, so remember that. And then what's k times last times suffix? Well, k is 10. 10 times 34 is going to be, 10 times the last number. What is 10 times the last number? Well, the last number is 4. That's 40 plus the suffix. Oh, we have 40 plus 74. So this is going to be 74. And, oh, wait. Did I mess something up here? I think this is actually 3. Yeah, did I mess that up? What do I think? Yeah, it's 3. Because the last digit previously was 3. Okay, yeah, I messed that up. My bad. So let's just do this again. N modulus 10 times m is going to be that's going to be 1 times 100, which is 100, plus k. What's k? K is going to be 10. 10 times the last number is going to be 30. 30 plus the suffix is going to be 64. So this entire thing is going to be 164. Okay, and on paper, you need to make sure you write this out, label everything, and So we should have gotten 134, but we got 164. So I know also that we could have just ran the test, and a lot of you might be thinking, what the heck am I doing? Why not just run the test? And here, we're going to run the test. And oh, I didn't save. My bad. Yeah. For a second, I was like, what? No. But yeah, it's failed. So yeah, as we expected, 164. But yeah, the reason I don't want to run tests is, like, of course, on the actual exam, you don't have a computer with you. So, and also a really great skill to be able to have is to be able to go through your own logic. And that's exactly what I did here. Okay, so basically, my gut feeling was right. This seems a little too complicated. So this is not right. And probably the way I'm doing M is also not right. And this is not right. So basically, we just need to... So we tried something, we got it wrong, we learned something. So what did we learn? Well, hey, regardless of whatever the solution I tried, what worked or not, I still need some way to keep track of the previous last digit and the current last digit. So our current last digit is going to be last, right? And then our previous last digit is going to, we need to basically find a way to keep track of that. So let's think about this. Let's think in this version again, in our second iteration. Let's basically erase all of this. We want some variable. So in the first iteration, we're going to only have to deal with the last digit, right? And then we want some variable. So in our first iteration, last was 4, right? So this is important. Now we want some variable to remember that the previous digit was 4, and we want now last to be the next one, right? So this is a little different from the logic we had initially, in which we were like directly computing this last 3 to just be an n modulus 10. But now I'm just going to do things step by step. So we want some variable to remember that the previous last digit was 4. So what some variable could that be? Well, the only variable I have right now is m. Okay, so what I can say is that m is going to be whatever this last digit is in the previous iteration. Okay, so m is going to remember what last was, and so then what do I have to check? If this works perfectly, I just need to make sure that every time through, last is less than m. Okay. So this will work in the second iteration. Will it work in the first iteration? Well, m is what? Initially 10. Is a digit always going to be less than 10? Yes. And this makes sense because every time through, we know there's going to be at least one iteration because of the fact that the shortest, longest increasing suffix I could have is 1 digit long. So this has to be true. It has to be true that this goes through the iteration at least once. I mean, at least this if case at least once, you know? And so to do that, if m is 10, this is always going to happen. So this is a big hint. It's very subtle, but this is how we could possibly solve this problem. So now that we have this, okay, in the first iteration, our suffix is just going to be 4, right? Because that's all we have. And then in our second iteration, our suffix is going to be 34. So let's see if we can build that. Well, what's k in our second iteration? Well, k is 10. Okay, this is really nice. So I can just do last times k plus some variable, which ends up being m. Sorry, not my some variable, my previous suffix. Sorry, that might be confusing, but we want to add it to the previous suffix, not m. Okay, and basically that makes sense because we want to build up our suffix. Okay, so let's take that logic, last times k plus the suffix. And let's see if this works. And actually, let's run through this once. So while n is initially going to be this large number, and then our last is going to be 4. And then initially our suffix is going to be 0, and our k is going to be 1, so we're just going to get 4 times 1 plus 0, and that's going to be 4. And the next time we're going to get 34, because we already walked through that. And the next time, we're going to get our last being 1, and our k is going to be 100. So 1 times 100 plus 34. And see, this is a lot simpler, and it's a lot easier to verify. So that I have a feeling that this is right. So let's just test it, and it's right. So now what have we basically just done? We've gone through a pretty challenging problem. So it doesn't look that challenging because there was only 4 blanks, but figuring out this if case took a lot of trial and error, and that's okay. So if it's okay, the one thing you don't want to do is get so stuck that you don't end up writing code at all. You want to work with the example. So here, I worked with this example because I thought it was very easy to understand, and I wanted to make sure it worked. And then if after that, basically, and anytime you feel like things are getting too complicated, you probably want to see if there's a simpler solution, like I did. And so that's basically the guide to figuring out these type of questions. Okay, so final takeaways. So whenever you're solving coding questions, it's really good to work with examples. So for example, in that longest increasing suffix question, I made sure I worked extensively with the first example. I made sure I wrote things out. I wrote out exactly what variables there were, and on a test situation, I might even write it out in an environment diagram exactly what's going on in each iteration. And also, another thing we learned is focus on small tasks first. For example, when we were working with reverse, it's a lot to reverse a number all at once. So the first thing we did is, hey, let's figure out the initial factor first. So we wrote, and then to do that, we had to figure out the length of the digits. So our first task was to write a helper function. And again, don't be afraid to define helper functions, whatever you need to solve the problem. Okay, so these are all. I think this is like a broad overview of some of the problem-solving techniques we'll see. When we work with some more complex problems, I will talk about even better problem-solving techniques, especially when we get into a topic called recursion. You'll see that there are a separate set of techniques for tackling those type of problems, but I think overall that these problems are good practice. So remember, the summaries we had some more simple questions. If you guys could get this, that's really good. If you couldn't get it, it's okay. Keep on practicing. And then we had these were definitely more challenging. This reverse number question was quite challenging because we had to, I don't know how many of you would have thought of writing a helper function. There are also several other implementations of reversing a number, but for me, that was the most simple. And then combining the two numbers, that was pretty cool. And then this number is prime. Remember, we talked about efficiency too with that, so that's also pretty cool. So I hope you found all these problems pretty interesting, and at least they made you think. I know, for example, this longest increasing suffix definitely made me think, and that's all I got today. Thanks for watching, and I hope you had a good time with these problems. I'll see you next time.